and Dr. Majarid is the Director of Emerging Infectious Disease Threats at the Walter Reed Army Institute of Research, and an Associate Professor of Medicine at the Uniformed Services University of Health Sciences in Bethesda, Maryland. On assignment from the U.S. National Institutes of Health to the World Health Organization, Dr. Majarid assisted in the response to the West African Ebola outbreak. His work focuses on the accelerated development of vaccines against viruses like Ebola and Zika that have triggered recent global health emergencies. So please join me in welcoming Dr. Kayvon Majarid.
Well, thank you very much to the organizers and for all of you. I'm hoping this will be an informative talk for you, a little bit different than the other speakers today. So let me start with a story. It starts with the low hum of a headache. Your back starts to hurt. Your whole body starts to ache. You think it might be the flu. But then you realize, it seems something different. It's not the flu. You start to develop a peculiar rash. You become nauseated. And if it's severe enough, your skin starts to bleed. You start to bleed from your mouth. And eventually your body succumbs. So you see the title of my talk, you probably know what you think you know what I'm talking about. I'm not talking about Ebola. I'm actually talking about smallpox. Smallpox, which preceded Ebola as a scourge of humanity for many years. In the last century, conservative estimates are that at least 300 million, maybe 500 million people died from this very deadly virus. 500 million people, it's hard to comprehend. About 4 times the number of people who died from all wars in the last century from this one virus. And as of 1980, poof, it's gone. We don't have to worry about smallpox anymore. Why? A shot in the arm. And all that's left is a memory, a reminder as a scar on the arms of our parents and those of us who were born in the 1970s or before. $1 for every person who died in the last year. That's how much it took. About 300 million in the last century, about 300 million or $500 million to eradicate this disease. So why would I waste time talking about a disease that hasn't existed for about 40 years? 2 reasons. One, though I'm not an economist, I'm not a businessman, it seems pretty clear to me that vaccines, illustrated by the vaccine for smallpox, is one of the most cost-effective measures that we've had in public health. 2, there were lessons to be learned from the smallpox eradication campaign that were applied to the Ebola outbreak. And I'll talk about that later on. But it took some time to learn those lessons. There's a country in West Africa called Guinea. It sat at the fringes of old African empires. It was an outpost for the slave trade. And it was actually one of the first countries to throw off the yoke of French colonial rule. And in the southeastern part of Guinea, there's a small hamlet called Meliandou, home to less than 1,000 people. And there in that village lived a toddler boy named Emile, 2 years old. Emile was like any other boy anywhere else in the world. But in December 2013, Emile got really sick. He got a high fever. He started vomiting. He started passing blood in his stool. In 4 days, Emile was dead. In the weeks following Emile's death, his sister, his mother, his grandmother, they all died of the same mysterious illness. By early March of 2014, 11 people had died in Emile's village and several dozen more in surrounding villages. This was ultimately found to be Ebola and the origins of the West African Ebola outbreak in 2014, which had never reared its ugly face in West Africa before. In fact, since it was first isolated and recognized in 1976, until it infected Emil's body in 2013, Ebola had caused about 24 outbreaks in equatorial and Central Africa. But each of those outbreaks occurred in distant, remote, forested areas where a few dozen or a couple hundred people passed from the illness, and then it burned out. Fast forward to 2014, 30,000 people become infected. 11,000, one-third of those individuals perish from the epidemic. It seemed at one point this snake-like virus was going to slouch towards the rest of the world and swallow us whole. But it didn't happen. So how was the outbreak finally controlled? Ebola is contracted through contact of bodily fluids, particularly at advanced stages of disease. So you might think there was some high-tech solution. There was some new medication, even a major breakthrough in vaccines that controlled the outbreak. Actually, it was very simple changes in behavior that changed the course of the epidemic. Strangers no longer embraced when they greeted each other. The Ebola handshake evolved, demonstrated here by the former UN ambassador from the US, Samantha Power, and the Liberian president, Ellen Sirleaf. And they're sort of demonstrating with lots of gusto. The other thing that happened, that was probably the most important thing to have happened during the Ebola outbreak, was that burial practices changed. So there's no better vehicle for transmission of Ebola than a corpse that has succumbed to Ebola. Very high load of virus in the body. And in this part of the world, burial practices involve the family and the community coming together, washing the body, caressing the body, kissing, embracing the body. You can imagine that presents great opportunity for transmission of the virus. Whole communities voluntarily and organically surrendered their practices, their customs, to designated Ebola burial teams. There was some education involved, but communities and community leaders really were the ones to recognize what the patterns were that were advancing the illness and what they needed to do to stop it. But then, midway through the outbreak, Ebola lands in Lagos, Nigeria, the largest city in Africa, a city of 21 million people, a teeming mass of humanity if you've ever been to Lagos. A nightmare for an epidemic to evolve, and evolve very quickly. So the world held its breath and braced for the worst. That is, everybody in the world except the Nigerian healthcare workers, the frontline workers, who knew how to deal with something like this because they had experience, they had infrastructure from the polio eradication campaign. Investments that were made 30 years before were paying off dividends for a completely different disease, a completely different scenario. Because people had operation centers, people had resources, tracking systems, surveillance systems to be able to halt the epidemic in Nigeria to just 20 cases. And really, we should be all grateful to those healthcare workers. The world should be grateful to them. But what about the vaccine? Didn't we have an Ebola vaccine? Wasn't that used to control the epidemic? Yes and no. At the start of the outbreak, we had a vaccine, but we didn't. Well, let me explain what I mean by that. We actually had a vaccine about 5 years ago, and really we had more than one. probably for about 10 years, but not one that had ever been tested in humans. A couple that had shown efficacy in mice and monkeys, but we as a society are in the habit of not deploying a vaccine or a medicine to thousands or millions of people when it's only been tested in mice and monkeys. So the global community was actually slow to respond. We had something on the shelves sitting there for 10 years. And once the outbreak was at its worst, the global community came together. Different sectors, funders, logistics people, healthcare providers, governments. After they overcame the initial inertia, they moved really quickly, particularly when it came to the vaccines. A collective effort of universities, small biotech, big pharma, governments, and philanthropies across continents came together within weeks to months. This was record time to test the safety and the ability of the vaccine to trigger an immune response. But then something happened that made the prospect of testing the vaccine pretty daunting. The cases started to fall. That's a good thing, right? You want the epidemic to wane. When it comes to people's lives, when it comes to people's health, yes. When it comes to testing a vaccine, it's challenging. So without new cases, there's no way of testing whether or not your vaccine works. Okay, remember when I said I told you that I was going to tell you about the smallpox and how it was applied to Ebola? This is the part where I tell you that. So wake up, pay attention. When the world committed to eradicating smallpox, it had to make the bulk of its investment in eliminating those last few cases. It was pretty easy in areas where there was good public health infrastructure, good tracking systems, and good access to healthcare to mass vaccinate populations. In those last few countries, places like Somalia, Ethiopia, Bangladesh, and Pakistan, in the late 60s and early 70s, it was very difficult to get out to all areas of the countries. So they had to come up with a different strategy of how to get those last few cases. What they did was, using the surveillance and tracking systems that had been built for years in the smallpox eradication campaign, once the case was identified somewhere, a team of public health professionals swooped down, and they didn't isolate that patient. They didn't quarantine its community. They vaccinated everybody around that person, a ring around that person. And then they vaccinated a second ring of contacts of those contacts so that they were able to interrupt transmission. There might be a few people that might still get the illness, but if they vaccinated enough people, they would interrupt the transmission, a concept in vaccine science we call herd immunity. The same strategy was used for Ebola and for testing the Ebola vaccine. Even with small numbers, they were able to focus on these rings of communities and magnify them for the ability to test whether or not a vaccine was effective. And it worked. How well it worked is up for some debate right now. But we know that nobody in those communities who got the vaccine for Ebola got the disease. The ring vaccination scheme serves as a good metaphor for how the response was finally accelerated. How this and other vaccine studies in very austere settings were launched, and how the epidemic was ultimately contained. Each ring, you can see, is a layer of stakeholders, starting with the patients and the volunteers themselves, going out to the community leaders, and ultimately to national stakeholders, global funders, global governing bodies. So let me tell you another story. A woman has just given birth to a baby boy, and she's been told that he's been born with severe neurologic abnormalities. She's also told that it's because of a viral infection that she got in her first trimester of pregnancy. She remembers having a very low-grade fever and a little bit of a rash, but nothing else. So, I tricked you the first time, I'm tricking you again. What is this? It's not Zika. You think that it might be Zika, because this is not Brazil in 2015, I'm telling you this story. This is the US in 1965. This is rubella, or German measles. Like Zika, when adults got the disease, it was mild, low-grade fever, rash. When fetuses got it, it was devastating. They developed something called congenital rubella syndrome. That was marked by neurologic abnormalities, sensory neural deafness, cataracts, born with cataracts, things that people in their 80s get, and severe heart malformations. But again, because of a vaccine, it's gone, no more. Shot in the arm, and in the US and developed countries, we don't have it. But there are still 100,000 cases around the world every year. These vaccines, smallpox, rubella, it doesn't happen easily. It doesn't happen initially cheaply. And it doesn't happen quickly. So from the time viruses are identified to the time we make a vaccine for them, it can take decades. Measles, 47 years. Polio, 45 years. Yellow fever, which is a cousin of Zika, 35 years. What about Ebola? 40 years. Zika, 70 years. Doesn't seem like it's getting better. Seems like it's getting worse. Until you look at a different timeline. When did we start trying to develop a vaccine for these diseases? You look at those older pathogens and compare those to Zika and Ebola, and the timeline shifts. It's actually contracted dramatically. But we have to actually start the program. If we sit around and say it's not an important disease, one day we'll get around to it, yeah, you're not going to have a vaccine. It's going to be decades and decades. And so speed is critical. Every month, every week, and sometimes in the setting of dynamic outbreaks every day. What if the next outbreak starts in Atlanta instead of Meliandou? What if it's airborne? What if it's intentional? That's one problem. Here's another problem. It's not just Ebola, it's not just Zika, it's not even just flu, Nipah, Lassa, Rift Valley fever, hantavirus. This is just a snapshot of the new infections, new viruses, new pathogens in the last 30 years. I'm not trying to scare you, or maybe a little. I'm trying to scare you a little bit, just so you'll pay attention. But it's not all bad news. Okay, though we keep discovering new viruses at an exponential rate, since we first identified what viruses are about 100 years ago, the number of new virus families that these new viruses are categorized into is plateauing. So yellow fever, Japanese encephalitis, dengue, West Nile virus, they're all the same family as Zika. SARS 10 years ago, MERS now, same family. Ebola Zaire, Ebola Sudan, Marburg, all the same family. We have seen these viruses before. We know what's coming. We don't have to wait for the outbreak to happen to start preparing for it. In the last century, the maxim of vaccine science was the 3 I's. Isolate the virus, inactivate the virus, and inject it into humans. It's clear that that is outdated, archaic. We need new guiding principles to meet the challenges of the new century. So let's start with the new 3 I's. Investigate. We need to get ahead of the curve, have better surveillance systems, figure out what is out there, what don't we know about, what kind of new viruses are on the horizon. And we need to use computer modeling. We need to use healthcare workers in the field. We need systems in place that are able to integrate all these different types of professionals with different types of background and experience and come up with some seamless program as to way to identify the new threats. We need to incentivize. We need to create incentives for industry to invest in vaccine development. 30 years ago, there were 30 companies making vaccine. Now there's pretty much 5. We need to give them incentives where there is no clear financial incentive for the next outbreak that they can't anticipate. And then, of course, the last one, I can't go through this whole talk at this meeting and not use this word, right? It seems obvious, but we're not always, particularly scientists, we tend to sometimes stay in silos. And so it took somebody with the idea that, hey, 40 years ago something worked for something completely different. Maybe we should try it for this Ebola outbreak. And the last, I'll add one more I to this. Maybe I should use ignite, but I didn't know how to apply that. So improvise. That's what we've been doing a lot of times. And we have to do. Even when we plan, we have to be willing to throw out those plans when we're faced with new challenges in the setting of a storm, a new outbreak, a dynamic outbreak. Sometimes you have to make it up as you go along. So I mentioned at the beginning that I'm not an economist, I'm not a business person, I'm a physician, I'm a scientist. This is a very different type of conference for me. I've never had theme music as I came up to give a talk. So very exciting. So when I was invited to this conference in the heart of Silicon Valley, I thought, wow, this is exciting. What should I do? What should I wear? Should I wear a black turtleneck and jeans? Should I put my hands to my chin at the beginning to declare I'm a thought leader? For your benefit and mine, I did not do that, okay? But I still leave you with a caveat in the words of Steve Jobs. People who know what they're talking about don't use PowerPoint. So I'll let you decide. Thanks very much.
That was great, Kayvan. Thank you.
Thank you.
By the way, my mum says you look very smart.
Oh, thank you.
Do you have time for a question?
Absolutely.
Super. Do we have, who's got the yellow boxes there? Well,
No questions.
over here. There we go. Thank you.
Sure. Good morning. Thank you. Question. Yesterday it was reported that bacteria-laden mosquitoes were released in Florida for Zika. So how do you look at what that will impact? Or do you have any reaction to that? I'm just curious. Thank you.
Yeah, sure. It's a really controversial topic. There's a trial right now in the northern coast of Australia where they've released, it's been several months where they released genetically modified mosquitoes to outcompete the mosquitoes that transmit diseases. And this is an idea that's gained a lot of traction but gained a lot of opposition as well. What are the impacts on the ecosystem if you introduce a completely new species that's genetically modified? The mosquito that transmits Zika, Aedes aegypti, is also the mosquito that transmits dengue and chikungunya. All these have caused huge public health problems in the Western Hemisphere in the last 20 years when they were primarily limited to the Indian Ocean basin and Southeast Asia. So the thought is, if you target that particular mosquito, you develop a genetically modified Aedes aegypti mosquito that is not susceptible to being infected with these viruses, and do it in a way that they outcompete with the other ones. You'll get rid of a whole species of mosquitoes that doesn't transmit a disease that's devastating to the population. We have no idea what unintended consequences those might have. So we have to be very careful in how we do these studies, how we assess the impact, and involving leaders in the community, ethicists, people who are not just focused on the science and public health to weigh in on if this is a good idea or not.
And we have one more question. Go ahead, Don.
That very unique and interesting perspective. It's got some things that probably resonate with this audience. You likely had to bring together a lot of different parties in your process to get this. And maybe you could spend a few minutes talking about how you brought together in a world where you're not part of the same organization necessarily. How did you bring these parties together? What obstacles did you hit and those kinds of things?
So that's what I learned when I went to the World Health Organization, when I was out on loan from the US government, and learned what role the WHO serves, because there's been a lot of criticism thrown at the WHO and its response, and some of it is valid. But as a normative body, its primary role is to bring together all these different stakeholders, different sectors of the population, bring together industry and government, private and public sectors. I think you still need, if it's not going to be the WHO in its current form, you'll still need normative bodies to be able to do that. Organizations that really have, when it comes to health, that have a stake in health and nothing else, and can leverage that kind of moral authority to be able to bring these folks to the same table.
Terrific. Thank you ever so much.
Thank you very much.